Hello, this is question 16 on June 2018, paper 1 from AQA. A remote controlled toy car is moving over a horizontal surface. It moves in a straight line through a point A. Toy is initially at the point with displacement 3 from A, and velocity v meters per second is given by this function. So we have that the velocity is 0.06 2 plus t minus t squared. And we know that when t is 0, so initially, the displacement, they call it r in this equation, so r is 3 meters. They ask, find an expression for displacement r in meters of the toy from A at time t seconds. So remember, we have the displacement called r, sometimes s, and sometimes x, if it's in the x-axis. Then the velocity, then the acceleration. So the velocity is the change in displacement. We derivate this way. That means we integrate in the other way. So we integrate the other way. If we have the velocity and we want the displacement, we need to integrate that one. Yeah, so we are going to integrate this to find the function displacement. So for A, to find r, I'm going to integrate the 0.06 2 plus t minus t squared dt. I can get the 0.06 out and then integrate each part. So I have 2t, yeah, this one when I integrate, I add the t. This one goes up by 1 and divide by 2. So plus t squared, and then I divide by 2. And the last one is minus t squared divide by, so I add 1 and divide by 3, and then I will have a constant of integration. Yeah, the information that they give us when t is 0, r is 3, is going to help us to find this constant of integration. So r is 3 when t is 0. So I have 0, 0, 0 plus c. So that means that constant is 3. So my expression is going to be, and I'm going to expand this bracket because the numbers are going to be okay. So 0.06 times 2, 0.12 t. 0.06 divided by 2 is 0.003. 03 t squared. And 0.06 divided by 3 is 0.002. So minus 0.02 t cubed plus 3, because that's the constant of integration. And this is my expression for the displacement. Then, in this question, use G 9.8. At time t 2 seconds, the toy launches a ball which travels directly upward with initial speed 3.43. Find the time taken for the ball to reach its highest point. So this is a Subat equation, a Subat equation question now. So we have a particle projected up, and it's really unrelated to the rest of the question. So we have a particle projected up that is going to go up and down. The initial velocity is 3.43, yeah, 34.3, and we need to find the time that it takes for the particle to reach the highest point. Yeah, we don't need to know the whole time, but just reaching the highest point. So we are going to write Subat. I'm going to choose positive direction up, for example. We don't need the displacement. The initial velocity is 3.43 and is positive because I say positive is up. Final velocity here is going to be 0. Remember, in the highest point is 0 because then it's reversing. So for an instant is 0. Acceleration is 9.8, but always the gravity goes down, and I say positive is up, so I'm going to write that negative. And because it's decelerating, so it's another way of thinking about it. And the time is what they ask. So I'm going to my list of Subat equations, and I look for one without s. That is, without s, is this one. This is the one that is missing s. So I'm going to write that v is u plus at, which means v is 0, u is 3.43 minus acceleration times the time. And from here, t is 3.43 divided by 9.8, which is 0.35. 5 seconds. They ask just the time taken for the ball to reach its highest point. That has nothing to do with these 2 seconds. We don't have to add them. I think it's a confusing line because I think you want to add those 2 seconds or do something with them, but nothing to do with what they are asking, yeah? And that's all with this question.